natural gas 28. So renewable 38, natural gas 28. Coal is 15%, oil 11%, and nuclear is 8%. So if you take the total energy produced across the world, this is for 2024, renewables dominated. So that's a very good thing. Also, we have to think about it as renewables keep on growing up. They come with challenges, right? So we are not going to increase renewables to 38%, and if that continues 2025 and the subsequent years, this is going to influence how we produce, transmit, and actually consume energy. There's going to be consequences. But the truth is that people need their energy, people need their electricity in their homes 24/7. Nobody cares about how they get their electricity. And we all have seen this. If you are in Ghana and there's a power outage, people say doomsaw. So doomsaw is a Ghanaian language. Doomsaw means that doom is off and saw is on. So it's like off and on, off and on. Once you lose your power, people are angry. People need their power. But also we have to remember that if you have solar, does a solar produce electricity all the time? That is the absolute no. So the challenges that comes is number one, the intermittency and variability of renewable energy. So when the sun goes to set, okay, we don't have electricity from the solar plant, but you and I sitting in our homes, we don't care. We need our electricity. We will not spare the government, or we will not spare the stakeholders running the power grid. Let's say ECG in Ghana or Gridco or VRA. We begin to complain because we need our power. Nobody cares about the sun. And when there is a slow wind, we know that the power produced from a wind turbine is directly proportional to the keep of the speed of the wind. So if you have a slower wind, it means that the power produced will be less. And so that is a problem. Wind is dependent on the location or the place. So not every part of every country has the same amount of wind. And so you cannot deploy wind power plant in every location. So that's also a limitation. And then also hydro is also having limitation because it depends on the head of the water at the dam. So, and if you look at the power equation for producing electricity from a hydropower plant, it's proportional to the head of the dam. So if you have the height, the head is the height, right? So when the water goes down, it means that the head has reduced and the power produced will be less. Okay, another thing that will be a bigger challenge with renewable growth will be policy and then politics, right? Most people or most engineers, we care about engineering, but the bigger influencer of whatever happens in every country or every industry, it comes with policy and politics. So you could have one government today that supports renewables, and another government will just come and then change the policy, and everything changes. So this is a bigger influence. Inadequate skilled labor is also a bigger challenge for renewables. Not a lot of people have experience in renewables. And so there's going to be a high demand for people who are well skilled, who have a good amount of experience and knowledge in how renewables are designed and deployed. The other limiting factor is technology is still growing. For the past 100 years, all the electricity we produce, most of it came from conventional energy sources like coal power plants. So now that we are changing, the technology has to change and adapt. But it will take time. New forms of technologies in terms of inverter-based resources for grid forming is on the rise. So if you know more about inverter-based resources, you know that solar uses an inverter to convert the DC power from the sunlight, and then change that to AC, and then that goes to the grid. But usually an inverter, now the dominant inverter type that we use is a grid following, which means that it's always going to follow the grid. So if you put a solar plant on, the solar plant per standard and code will have to wait. The inverter has to delay by 300 seconds or 5 minutes before it's able to inject power to the grid. But think about it, the customer in their homes, they don't have patience to wait for 5 minutes. We need our power. So, but grid forming inverter is something that will come and change that kind of dynamics and give more flexibility in how we deploy energy. Okay, challenges, but we have talked about sustainable energy, what it is, and then how it is growing. And everything shows that sustainable energy or renewable energy is growing. And then we talk about the challenges with that will come along with that. But also we need to think about it this way, like challenges, whenever there are challenges, it comes with opportunities. It happens in our personal life, in everything. It depends on how you look at problems. Every problem that you face in life, the other side is that if you think about it deep, it comes with opportunities. The same way with renewables, renewable is growing so fast, but it comes with challenges. And these challenges create opportunity. We all know that renewables will be needed. And this will never change, it's guaranteed. As far as human population continue to increase, as far as we continue to build businesses and build new homes, this will increase demand. And as demand is increasing, it means that these people will need energy. They will need electrical energy here. So if you need electrical energy, then you have to build more power plants to be able to meet the demand. And always to keep a grid, you need the demand and the supply to be the same, right? And we also know that now there is high growth in AI and data center. Data centers, that is driving energy demand so well, because data centers would use a lot of cooling. And so it's because of the cooling that, you know that even if you have air conditioning in your home, your electric bill is going to increase. So cooling is something that needs a lot of energy. And that is why we need, even though there are challenges, but the opportunity is that there's going to be demand. And the demand is that, the opportunity is that natural gas, if you look at natural gas and nuclear power plants, they take longer time to build. If you want to build a nuclear power plant, it can take you like 10 years or more. But I don't think people will want to wait for 10 years. So nuclear power plants is a long-term plan. It also has like complex processes that you have to follow a lot of regulations to comply to be able to build nuclear and gas power plants. Most coal power plants are being retired, and HFO or heavy fuel oil plants are also banned in many countries. When I used to work in Ghana, in Ghana, the power plants, AXA and Car Powership, at the beginning, they were using heavy fuel oil, but because of environmental conditions, they have not changed to natural gas. They've made a lot of retrofits and then changed the plant to gas because HFO is banned. But the option is that renewables are faster to design and build as compared to having nuclear and then coal power plants. So here also, it means that renewables still have the competitive advantage of being the leader of the future of energy. So that's good news for us. Okay, let's come to the second point, which is the skills. We've looked at sustainable energy. We will not be able to cover everything about sustainable energy, but this is a 1-hour webinar. And so that's the brief we can discuss. The skills here, it's very important that we build skills. Very important. And as a matter of fact, most of us, I was also a victim of that when I was in school. I thought like school was everything is about school, but that is not the case. based on experience, nobody usually cares about school. Nobody. I like school a lot. I like to learn a lot, but nobody really cares about the knowledge in school, because the knowledge in school is different from what is happening in the real world. So in the real world is different, in school is also different, but the school is very important. So what matters is that the school usually will get you into the door, but what actually will take you very long way is the skills. So let's look at some of the skills that are very important for electrical engineers or people who are energy enthusiasts. Skilled is the differential factor. We need to build our skills. We need to, first of all, if you're starting your career, I would recommend thinking about designing. Designing gives you the foundation of everything. So if you can start your career in anything, but if you want to really understand engineering and have expertise knowledge as you progress, you need to start designing. How do we put, if you look at the power plant, how was it designed? This is a very complex process. Where does it start? Where does the concept come in? And then how do you translate the concept into a paper? And then how the paper is a drawing package. And then